lesson is to cover exercise 7D, which is the ideal effective or annualized interest rates when you have different compounding interest investments. Why is that important? Because if you've got compound interest investments with one matching property, for example, the interest rate or the compounding frequency, you can compare them easily. For example, is it going to be easy to determine which of these investments is going to be better out of A or B? Which is going to be better, 5% compounding monthly or 5.1% compounding monthly? If you were going to put your money in the bank, what would you prefer? Which one? Yep. Why is that easy to compare? Because they have matching compounding periods. If we look at this second one, 4.5% compounding monthly or 4.5% but compounding quarterly, which one would I want to put my money in? The monthly. Why? Because it's compounding more often, even though they're the same interest rate. You're going to get slightly more money. But if you have compounding interest investments that have different interest rates and compounding periods which are quite similar, it can be hard to compare them. You don't know which one's better. For example, 6% compounding half yearly or 5.94% compounding monthly. We don't know which is better. 6 sounds better, but it's only compounding twice a year. 5.94% is lower, but it's compounding 12 times a year. This situation is like comparing apples and oranges. There's no matching property. They're too similar to be sure which is better. So the point of the effective annualized interest rate is the effective rate is what it would be if it was compounding annually, one time a year. So if you convert the nominal rates, the stated interest rates of different investments to the effective rate, you can easily compare them. You can compare apples to apples. This year, I'm not going to show you the calculator method. If you're interested in using the calculator method, I can show you after. I'll just give you the formula. So this formula can go on your cheat sheet for the effective annualized rate of compound interest investments. I is the nominal interest rate as a decimal. K is the number of compounding periods. Like I said in this red here, I'm only going to teach the formula this year. Then we'll do an example. A. So the example is asking you, can you consider the two investment options below? A, 4% compounding monthly, or B, 4.2% compounding quarterly. Calculate the effective rate of each, and then B, which is better. So obviously we want to work out which has the higher effective rate. So using that formula, what is 4% but as a decimal? Good, 0.04 divided by K, as according to that formula. If it's compounding monthly, how many times is it compounding in a year? Yep, 12 to the power of K, which was 12 again, and then you're going to subtract 1 from the answer. So be careful with BEDMAS on your calculator. Work out what 0.04 divided by 12 is to start off with. Add 1 to it. Raise it to the power of 12. And then you take 1 from that answer. So the effective rate is going to be 0.041 to 3 decimal points. But that's not a rate, that's a decimal right now. What percentage would that be? With 0.041, what percentage would that be? 4.1% per annum, effective rate. That's for A. For B, effective rate equals, again, 1 plus 0.042 this time, divided by, if something's compounding quarterly, how many times does that happen in a year? 4 to the power of, what do we say, 4. Then take 1 from the answer. Calculator again, 0.042 divided by 4, add 1, raise that to the power of 4, take 1 from the answer. That gives me 0.043 to 3 decimal points. So 4.3% per annum effective rate. According to that information, which bank would be better?
Bank B.
Yep, why?
It's got a higher
Yep, B is better because it has higher effective rate. Can you get that example down, please? So please, you only use that formula when you're finding the effective rate of a compound interest investment. When we do loans, there's another thing called effective rate for loans. There's a completely different method of answering. Use TVM solve. Don't get the two mixed up. Now, if you got the example, unfortunately we need to cover this just in case. It's the idea of an effective annualized rate of a simple interest investment. There are no exercises for it. If you look in your textbook, there's like an investigation in orange. Why do they do that? Well, SACE only asks for it every so often in the exam. Every so often SACE asks a question in the exam that is a simple interest investment and they want to find the effective rate. This formula above is only for compound interest investments. They only ask this rarely, so they didn't dedicate a whole set of exercises for it. So what I will do is I'll provide you a set of steps that works for it. We can do an example. Just chuck that on your cheat sheet. There will be no timeline dedicated to finding the effective rate of a simple interest investment. So if you've got this example, can I give you some time to get these steps down here for finding the effective rate of a simple interest investment, and then I'll show you how it works. So I'll get back to you at 1:15. What's cut off there is the formula that I think you've got. Yeah, in that box, it's got the inputs. Yeah. So again, this second section here, I want to cover it, I don't want to leave it blank. Your book doesn't have exercises for it, but SACE asks for it every so often. You'll need a dedicated cheat sheet room for this. It's been like once every 3 years or so. Sneaky, sneaky.
You think they'll put it in this year?
They used to pretty solidly alternate difficulty of exam. Easy, hard, but then it changed last year. They had 2 easy ones in a row. So let's not predict. 2022 and 23 are nice exams. You're due for a hard one, I'm sorry to say. Three minutes and I'll go through those steps. Do make sure you get this little bit in bold. Sometimes it doesn't tell you how much is being invested in that simple interest thing. If you're not given a starting principle for this kind of question, you can literally make one up. You can just say $100. Okay. Example, suppose $100 is invested at a flat rate of 6.5% per annum for 5 years. Find the effective annualized interest rate for this investment. The reason why we have a separate example here is because this says flat rate, which is another word for simple interest. So you need to apply these steps to it. Why do we need a special thing here? Your book doesn't have exercises for this, yet SACE asks for it every so often. So this should just go onto your cheat sheet. Step 1. Use SI is equal to PRT to find the simple interest earned. So SI equals PRT. I invested 100 times by a rate of 6.5, so 0.065 times by 5 years, times by 0.065 times by 5. That would earn $32.50 in interest. Step 2, find the total value of the investment by adding the principal and the simple interest together. So total value, I put in 100, I earned $32.50, so the total is going to be $132.50. And then you have a whole bunch of TVM solver stuff to do. N is the number of years of the investment. What did the question say the number of years was? 5. I is what you are solving for. PV. PV is the original principal as a negative. So in the simple interest situation, what did they invest? 100. So it's going to be negative 100. PMT is nothing. FV. What does the step say for FV? The total value of the investment is a positive, which was $132.50. And PY and CY are both, according to this, 1. So you jump over to TVM Solver, Apps, Finance, TVM Solver, 5, negative 100, 0, $132.50, 1 and 1. Solve for I. That tells me the effective rate of this simple interest investment was 5.79 to 2 decimal points. So the effective rate for this simple interest investment would be 5.79% per annum, rounded to 2 decimal points. This will only exist on your cheat sheet and in your notes in your book. There's no exercises for that. If you've got everything down, finish your homework, and now is effective rates. What was that? I think it was 7D. Exercise 7D, please.